Hello everyone, myself Avnish Tiwari, Assistant Professor in Civil Engineering Department at Sri Ram Swaroop Memorial College of Engineering and Management, Lucknow. Today in this lecture we are going to discuss about laying and testing of water supply pipelines. Following topics will be discussed: structural requirements of pipe, laying of water supply pipelines, and next one is testing of water supply pipelines. So, what is structural requirement of water supply pipelines? Basically, the pipeline which we are going to design for the purpose of water supply, that should be capable of withstanding all the external as well as internal loads, and its own weight and different dynamic force acting on the pipe was also considered. When we group all the different forces, following forces comes into the play. First one is internal pressure of water, and this internal pressure of water includes water hammer pressure, and this water hammer pressure will be resisted by the pipe material itself, and the pipe material which is used, it should be strong in tension. Next one is pressure due to external loads. Pressure due to external loads includes backfill, means the external loads can be in the form of backfill or in the form of traffic loads, and this type of pressure is again resisted by the pipe material, and that pipe material should be strong in the compression. In case of water hammer pressure, the pipe should be strong in tension, while in case of external loads the pipe should be strong in compression. Coming to next stress, that is longitudinal temperature stresses. This type of stress comes into existence when the pipe are laid above the ground, and this type of stress can be resisted by providing an expansion joint. Okay. Next one is longitudinal stress, and this longitudinal stress is due to unbalanced pressure, and this unbalanced pressure can be seen at bends or at the point where pipe changes its cross section. How this type of stress can be resisted? This type of stress can be resisted by firmly anchoring the pipes in a massive block of concrete or stone masonry. At point A there is a bend, and at that particular point there is a development of unbalanced force, and because of that unbalanced force there will be development of a longitudinal stress. Okay. Coming to next stress, that is flexural stress. Flexural stress produces when the pipe are supported over the trestles. For example, these two are supports and the pipe is passing above it. What will happen when water will flow through this pipe? The pipe tries to bend and there will be development of flexural stress. What will be the internal pressure of water, or how can we calculate it? As the pressure exerted on the walls of pipe by the flowing water in the form of hoop tension, the value of circumferential tensile stress will be sigma equals to P into D, sigma equals to P into D by 2 into T. How can we get that value? Consider a pipe. The pipe is having a thickness T. Okay. So, there will be existence of pressure and that pressure will be registered by stress. So, here develops a stress and that value is sigma. Similar stress will develop on that side. What will be the value of force? In order to get the force, what we will do, simply we multiply sigma by area, sigma into area, and what will be the area? Its area will be equals to sigma into L into T, means basically what is the length and what is the thickness of that particular pipe. As the stress development on both of the side, so it will be multiplied by 2, means force develop 2 sigma L into T. And what pressure applied by the water? That pressure will be on that point or that particular portion. So, if we draw its top view, it will be like that. The pressure exerted by water from that much portion, and in order to get the value of force, what we will do, simply we will multiply pressure into area. What will be the area? Its area will be diameter into length of pipe. Equating both the values, what we will get, P into D into L equals to 2 into sigma into L into T. L cancel out and sigma will be what? Sigma will be P into D by 2T. So, this is the value of sigma. And how can we get the value of sigma? So, here sigma is circumferential tensile stress, P1 is the internal static pressure, its unit is in kilonewton per meter square, T is thickness of pipe in meters and D is diameter of pipe in meters. Next one is water hammer pressure. So, what is water hammer pressure? Basically, when a liquid flowing in a pipeline is abruptly stopped, and how can we stop it? By closing a valve, the velocity will reduce to 0, and if the velocity reduces, then what will happen? Momentum is destroyed, means momentum also reduces, and this exerts a thrust on the valve and additional pressure on the pipe cell behind. This is the case, here the water is flowing continuously. If we are going to close the valve, what will happen? The valve is closed and the flow of water is abruptly stopped, and the flow of water exert pressure on the valve as well as the surrounding cell of pipe. And what results? The more rapid the closure of valve, the more rapid is change in momentum and greater will be the internal pressure developed, means rapid will be the closure of valve, rapid will be the change in momentum and greater will be the development of additional pressure, and this pressure so developed are known as water hammer pressure. The pressure developed because of the sudden closure of valve will be known as water hammer pressure, and what will be the result? It will cause the bursting of pipe. So, 10 times what will happen? The pressure is too high that it bursts the pipe. And how can we calculate that particular pressure? For estimating the value of water hammer pressure, we are going to use expression P2 equals to, here P2 is what? P2 is water hammer pressure, 14.762 into velocity, V is what? Velocity of water flow just before closing the valve, and it is in meter per second. What is D? D is diameter of pipe, and what is T? T is the thickness of pipe, and K is constant, which is the ratio of modulus of elasticity of pipe material and bulk modulus of elasticity of water. How can we get the value of K? Basically, The value of K for steels comes out to be 0.01, means for different pipe material the value of constant K will be different. For cast iron pipe the value of K is taken as 0.02, and for cement concrete pipe the value of K is taken as 0.1. And while designing the water supply system, what the value of water hammer pressure should be taken as? For design purpose, if values are not given, we can take this much of water hammer pressure for different diameter of the pipes. Okay? And this water hammer pressure can also be calculated by using the formula mentioned earlier. And the circumferential tensile stress, next what we are going to do, we are just going to convert water hammer pressure in the form of stresses. The circumferential tensile stress produced by water hammer pressure will be what? Sigma equals to P2 into d by 2t, where P2 is what? Pressure because of water hammer action. Okay? And next is stress due to external loads. These external loads are backfills which produces stress in the pipe material, and this stress can be simply calculated by using the expression that sigma equals to 22.7 into h into d square by 2, where sigma is stress produced in kilonewton per meter square, d is the diameter of pipe in meter, t is the thickness of pipe, and h is what? H is the depth of earth which is taken above the crown. Means if this is a pipe and this is a portion where the pipe are laid, the pipe is laid, what will the value of h? H will be this much. Okay. So, h is what? H is the depth of earth fill and it is taken above the crown. In above formula, it is assumed, if basically the formula is derived by having certain assumptions, it is assumed that earth to the side does not give any lateral support and the weight is about 18.4 kilonewton per meter cube. Coming to next, that is temperature stresses. This type of stress develop because of variation in temperature, and this generally comes into existence when the pipe is laid above the ground, means pipe is exposed to atmosphere, and when the pipe is exposed to atmosphere there will be change in temperature and the pipe will expand during daytime and contract during night time. So, our target is to neutralize this expansion and contraction. So, this expansion or contraction can be prevented by using expansion joint. We can control it by providing an expansion joint. So, if this expansion or contraction is prevented due to fixation or friction over the support, longitudinal stress are produced in the pipe material. Okay. So, there will be development of longitudinal stress. What will be the value of temperature stress? Basically temperature stress equals to E into alpha into delta T, where E is what? Modulus of elasticity, alpha is coefficient of thermal expansion which is dependent upon pipe material, and delta T is what? Change in temperature. And in order to counteract that stress, the expansion joint provided, it should be at an interval of 20 to 30 meter, and that counteract the temperature stress. Next one is stress due to flow at the bend, where what is developed? There is a development of unbalanced pressure. So, whenever the velocity of flow changes and that change should be in the form of magnitude and direction, what will happen? There is a change in momentum. What will happen? There is a change in momentum, and we all are aware that according to Newton's second law, force should be exerted because force is directly proportional to change in momentum. Okay? The force required to bring this change in momentum comes from pressure variation within the fluid. Okay? There is also possibility that if the cross section changes, there will also be a pressure variation. Okay? Pressure variation, and from forces transmitted to the fluid from the pipe flow. And when we are going to draw the free body diagram, the diagram should be like that. Okay? What is this? This is the section 1 and this is section 2. What will be the force? Here force will be pressure multiplied by the cross sectional area at point 1 and what will the force at point 2 at section 2. Here the force will be pressure multiplied by area at section 2, and there also comes a force in direction x and a force in direction Fy. And what we are going to do, just we are simply going to equate force equals to change in momentum, force equals to change in momentum, and after equating that we get the values P1 A1. What will happen? There will be the force in x direction, that is P1 into A1. Fx comes into existence in opposite direction, that is why minus x. Here the force P2 A2 acting in this direction. When we are going to resolve it, then when we are going to resolve it, what will happen? This is the value, this is theta, this is theta. What will be this? This is again theta, and what will that component? That is P2 A2 cos theta. Okay. So again in opposite direction, so minus of P2 A2 cos theta equals to mass, and mass can be written as what? Gamma W by G into K. This gives us mass, and what will the velocity? Change in momentum equals to mass into change in velocity. Here what will the velocity? Here at point A velocity is what? V1, and here what will the velocity? Here velocity will be V2. When again we are going to resolve it, the component comes in x direction is V2 cos theta. So final velocity minus initial velocity, that is V2 cos theta minus V1, and in Fy direction the force acting upward, that is Fy. So it is Fy. The force in downward direction is P2 A2 sin theta. So that will be Fy minus P2 A2 sin theta equals to change in momentum mass into velocity. The component of velocity in y direction is 0, and the component in y direction is what? At point 2 is V2 sin theta. So this can be written as V2 sin theta minus 0. So by using these two equations we can estimate the value of Fx and Fy at a point where bend is observed. Next one is flexural stress. So coming to flexural stress, basically this type of stress develops when the pipe are laid above the ground and supports are given at regular interval. What will happen? The pipe will act like a beam and the columns will act like a support, and when water will pass through it, the weight of water as well as the weight of pipe itself tries to bend that particular pipe, and by resisting that particular load or that particular self weight of pipe, there is a development of flexural stress. Okay. So this is a form of stress which develops in a pipe because of supports. Next comes to laying of water supply pipeline. So basically pipes are used for conveying water from source to city and also for distributing the same within a city. So it can be used for transmission of water from source to city and then distributing the water in the city, and this pipe can be laid above the ground or below the ground. Okay, it can be laid above the ground or below the ground. Generally the pipe bringing water from source to city are laid on the ground. This is a picture which is just showing how the pipe is laid above the ground. Okay. Whereas the pipe used for distributing, because distribution system is designed in a city and it is not practically possible that the pipe is always exposed on the ground or above the ground, then in that case the pipe is laid below the road and streets. When the pipe is laid on the ground, what will happen? We have to compact the ground surface, that ground surface should be compacted, okay? And why compaction should be done? Compaction should be done in order to avoid settlement in the future, and it is mandatory that the pipe should not be laid just above the ground. It should be laid over small masonry or cement concrete support at an interval of 16 to 12 meter apart. Okay? This arrangement will be helpful in order to perform the maintenance work, repair work or inspection work. This flow diagram will just represent the step involved in laying of a pipe network. Firstly, what we have to do? Basically, we have to line out and excavate the trench, and after the excavation of trench, what we are going to do? Just we are going to use pipe of suitable length, and after getting the pipe of suitable length, we are going to just lower the pipe in the trenches, and after lowering the pipe in the trenches, what we are going to do? We are just going to join the pipes. After joining the pipe, we are going to partially fill the trenches. Why partially filling the trenches? Because we have to perform pressure test. Okay? After performing the pressure test, we can completely fill the trench and compact it. Okay? So, these steps are just elaborated in the following steps. So, in order to line out or draw or just we have to mark the distribution system, we need a detailed map which shows a road, street, lane, so we can plan for it. And after getting the maps, what we are going to do? Just we are going to draw the center line of pipe, and this center line of pipe should be transferred on the ground. And after transferring the ground, what we will do? Basically, we are going to excavate it, and while getting the excavation, certain points should be remember that the width of trenches should be 30 to 45 centimeter more than the external diameter of pipe, and at the point where we have to make joints, the depth of excavation should be 15 to 20 centimeter more and for 1 meter of the length, so that joining of pipe should be easy. Okay. So, next one is the pipe should be laid more than 90 centimeter below the ground. Why 90 centimeter below the ground? Because of that the impact of traffic load can be minimized. Okay. And after performing the excavation, the pipe are lowered in it, and after getting the pipe lowered, what we are going to do? We are simply going to join it, and after joining it, we are going to perform water leakage and pressure test, and after successfully completing the test, what we are going to do? Basically, we are going to just fill the trenches and compact it. Next one is testing of water supply pipelines. Coming to testing of water supply pipelines, few points should be known by everyone, that is working pressure. What is working pressure? Basically, working pressure is actual maximum pressure, also including water hammer pressure, to which the pipe will be subjected during its operation. What is design pressure? Basically, design pressure is a maximum pressure for which the pipe has to be designed, and this is obtained by simply multiplying the working pressure with factor of safety. When we multiply working pressure with factor of safety, we will get design pressure. Next is test pressure. Test pressure is a maximum pressure which pipe can withstand without any leakage when we are going to test it for the leakage. Okay. After laying of pipeline, the soundness of construction is examined. And how it's examined? Basically it is examined by performing the test, and the pipe is tested section by section, and at a single time we are going to perform testing of a single section, and that particular section should be between two sluice wall. The downstream sluice wall should be closed and water is allowed to enter from the upper sluice wall. Okay. And next is that we have installed pressure gauge at different pipes of the different point of the pipe along the length of pipe section at a suitable interval, and that is 1 kilometer interval. And next one is the pressure of pipe is raised by means of a small hand force pump or a hydraulic pressure pump till the test pressure is achieved, and this test pressure is about 25 to 55% above the highest working pressure. Next one is the pipe and joint are then visualized for water tightness. The applied pressure should be maintained for at least 4 hours. Okay, the pressure applied is maintained for 4 hours. When field test pressure is less than third of the work test pressure, then the observation period should be increased to 24 hours. And after testing the pipe, if observation comes that there is a leakage, then what we are going to do? Just we are going to repair it, and after repairing it we are again going to test it, and if the test comes satisfactory, then that particular supply system will comes into existence or comes into our use. These all are the references. Hello everyone, myself Avnish Tiwari, Assistant Professor in Civil Engineering Department at Sri Ram Swaroop Memorial, College of Engineering and Management, Lucknow. Today in this lecture we are going to discuss about pipe joints, pipe appurtenances and pipe walls. So, following topics will be discussed. First one is remaining portions of previous lecture, that is certain pipe joints. Next one is pipe appurtenances, pipe walls and leakage in pipes and the way to control the leakages. So, in previous lecture we have discussed bell and spigot joint and flange joint. Next one is union joint. So, basically in this joint what we are going to do, basically two ends of pipe are joined by the means of union. And what is union? Basically union is a type of fitting which is designed in such a way which unites two pipes, and this type of joint easily detach both the end of pipe without causing any deformation to the pipe. And in a pipe union basically there exist three parts. First one is a nut, a female end and a male end. In a single pipe union there will be a nut and a male end as well as a female end. So, these two ends are basically connected to pipe, male end as well as female end, and after getting it connected to the pipe with the help of this nut we are going to join both the ends of pipe. Okay? And this is a picture which representing the use of union joints. Next one is nipple joint. In nipple joint two pipes are joined basically with the help of pipe fitting, and that pipe fitting is nipple, and this nipple is basically nothing but a piece of pipe having thread at the both ends. Basically this can be seen from these two figures where both the end is having thread, and this pipe fitting is basically used for short extension of plumbing lines, and this short extension can be in the forms of connecting two pipe fitting with a small distance. There is a disadvantage, and this disadvantage is that this joints reduces the area of flow, because what we are going to do, we are going to tight the pipe on this thread, and the area of flow available is what, this much. So, there is a reduction of area, and this reduction of area is equivalent to the thickness of pipe. Okay? So, this results in reduction area of flow. Next one is mechanical joint. In this type of joint is used when it is required to join plain end of cast iron pipe, means there is no provision of flange, there is no provision of bell end, then we are going to use mechanical joint. In this joint a special type of metallic collar is fitted over the pipes. So, these are the end of pipe over which what we are going to do, we are basically going to use a special type of metallic collar. Okay? And this metallic collar is fitted and then tightened over the abutting ends, and the resulting will be mechanical joints. The most common joint is dresser coupling. So, dresser coupling is a most common joint. So, a gasket and a iron ring are slipped over each of the abutting ends. So, basically this is a gasket, and above the gasket an iron ring is placed and an iron sleeve is inserted in between the gasket. The iron ring are then tightened by means of nut and bolts. So, basically the iron rings is placed above the pipe and then it is tightened with the help of nuts and bolts. These joints are strong and rigid, okay, these are strong and rigid, that is why they can not be used at the point where there is a vibrations, and therefore they are useful in the case of pipes that are going to carry water over the bridges or below the bridges. Coming to next joint, that is flexible joint. By the name it is clear that this joint is going to offer flexibility. Okay. So, the point where there is a requirement of flexibility at large scale, we are going to use this joint, and the point where this joint is required is the areas with uneven beds, and this uneven beds can be easily seen when the pipe is going to pass through a river, or we can say the point at which there is a possibility of settlement at large scale. If there is a possibility of settlement at large scale, then the pipe is going to break. So, this can be avoided by using this type of joint. Okay. Or we can say that if we are going to use pipe on the curve, then there is also need of flexible joint. In case of this joint, there should be pipe with one end normal, and the normal end is carrying bead at the end. Basically this is what? This is bead, okay, and another end is enlarged, and this enlarged end is in the form of bell. Okay. So, the socket end or the bell end is in the form of spherical, and the spigot is plane, which can be seen from the figure, and the spigot is having bead at the end, and between the spigot end and socket end, what we are going to do, we are just going to place a retainer ring over the bead, we are going to place retainer ring over the bead, and after that there will be rubber gasket, and after placing the rubber gasket and retainer ring, we are going to place a gland ring, and these arrangements are tightened with the help of again nuts and bolts. Okay. And when after tightening it, what will happen, we get a flexible joint, and the pipe will move on that surface when it is going to subject on the vibrations or at the time of deflection. Next one is expansion joint. These joints are used where the pipe is going to subjected on the thermal stress, okay, and this joint is provided at a suitable interval in the pipelines. So, for providing the expansion joint in a cast iron pipe, the socket end is cast flint. So, here the socket end is not in the form of sphere, but it is in the form of cast flange, and the spigot end is plane, the other end is plane. The socket end is connected rigidly to the annular rings, and it can slide freely over the spigot end. On that particular end, our annular ring is going to move freely. While making this joint, a small space is kept between. Why small space? Because at the time of expansion, what will happen? The pipe tries to expand, and when it going to expand, then there is a need of space. If there is no space, then the pipe is going to again burst, okay, because of the expansion. So, when the pipe expanded, the socket ends move forward and the gap left just closed, and when pipe contracts, what will happen? The socket end move backward, means during expansion it will move in this direction, while during contraction the pipe is going to move in that direction. Okay. So, it will move, and the movement of what? The movement of a socket end. So, socket end comes closer, while in case of contraction the socket end will move far away from that particular point. Next topic is pipe appurtenances. Basically, what are pipe appurtenances? Pipe appurtenances are the fixtures or attachment that helps in isolating and draining a pipe to perform inspection, testing, cleaning and repair work. Okay. In order to isolate and drain the pipelines, section for test, inspection, cleaning and repair, a number of appurtenances are used, and these appurtenances are such as gates, walls, manholes, insulation joint, expansion joint, anchorage, and these are provided at a suitable interval. This is a clear picture which is just showing the positions of different types of pipe appurtenances or walls, and the head at the reservoir end and the head at the storage end, where from where the water is going to be distributed and the point where water is going to be stored. Okay. So, this will be the static head when there is no water flow, and this will be the hydraulic gradient line, that is summation of your pressure head and datum head. So, these are the summit points, these are the bottommost point. At summit point we are going to provide air valves, gate valves, and at the bottommost point we are going to blow off valve or drain valve. These are going to remove the water, drain valves, and these are air valves which are going to either allow air to escape from the pipe, either allow air to move inside the pipe. Okay. So, first one is gate valve. What is the purpose of gate valve? Basically, gate valves is used in order to regulate the flow of water. They are used to regulate the flow of water, and in large pipelines bringing water from source to city, and they are generally located along the pipelines at an interval of about 3 to 5 kilometer, and the provision of gate valves divides the pipe into different sections. Thus, at the time of repair only one section can be cut off at a time. By closing the gate valve both the end, one section can be easily repaired. Okay. For that purpose, at which point that gate valve should be provided? This gate valve should be provided at the summit. At this point the gate valve should be provided at this point, not at this point. Why this so? Because at this point low pressure head is available. If low pressure is available, then the pressure acting on the gate valve is also low. So, it can be cheaper and less stronger material. But if we are going to provide gate valve at this location, what should be the result? The result should be that we require larger strength of gate valve, and it will also increase the cost. The most commonly used type of gate valves is shown here. Okay. There is a spindle, this is a wedge shaped circular disc, and this is basically wheel, and this wheel can be operated by hand or by a mechanical arrangement. Okay. This consists of cast iron with a brass, bronze or stainless steel mounting. The end of valves are properly jointed on both sides of the pipe length by suitable standard joints. Means this and this should be properly joined to the pipe. The valve consists of wedge shaped circular disc, which can be clearly seen from this figure, fitted closely in the recess against the opening in the valve, and this is connected to wheel or handle. This is connected to wheel or handle, which can be rotated by the means of thread provided in this particular rod, and during opening the valve moves upward, and during closing the valve will move downward. Next one is air valve. Basically, air valve is a special kind of valve which are generally placed at the summits. They are provided for two reasons. One is that they allows air to move inside the pipe. When vacuum is created, they allows air to enter in the pipe. They allows air to enter the pipe. For example, if there is a gate valve and if we are going to close it, what will happen? After closing the valve, the water next to the valve will stop moving because of creation of vacuum. If there is a air inlet valve and we open the air inlet valve, what will happen? The water behind the valve, behind the sluice valve can easily move. Means in order to remove the vacuum created inside the pipe, we need air inlet valve. And what will happen during the repair work? During repair work, when the supply is restored, the air get entrapped inside the pipe. The air get entrapped inside the pipe. If we have repaired this particular section, and after repairing work, if we start the flow of water, what will happen? The air inside the pipe get trapped, and in order to remove the trapped air, we need air outlet valves. So, this can be of two type, air inlet or air outlet valves. So, this is a picture which showing automatic air inlet and outlet valve. So, how can this operate? What will happen when vacuum created inside the valve? This particular float move downward, and when it moves downward, this portion opens and the air will move inside. In secondary case, what if air get trapped inside the chamber? Again what will happen? If air get trapped inside the chamber, then again the level of water will fall, and if the level of water will fall, the float will move downward, and again the valve will open, and then the trapped air will move outside. So, air outlet valve is known as air relief valve. Next is blow off valves, drain valve or scour valve. What is the purpose of blow off valve? Basically, these are provided at the lowest point. Why lowest point? Because they are basically used for the purpose of removing the water at the time of repair or maintenance work. We are going to provide drain valve at summit points. What will happen? If we are going to provide blow off valve at summit points, then the water in that particular portion will get trapped. So, in order to remove the water between these two sections, it is obvious that we need a valve and it should be at the bottommost point. So, these valves are provided at lowest point, which after closing the supply of water should be opened, and after opening the valve it allows the water to completely move from the pipe. Okay. So, that is the reason why we should provide it on the lowest point. There should be no direct connection between the valves and the sievers. Why so? Because if there is a direct connection, then after getting the pipe emptied, there will be chances that the sewer water may move inside the pipe, and which will pollute the water distribution system. Next one is pressure relief valve. What is the purpose of pressure relief valve? Basically, they are going to reduce, and what they are going to reduce? They are going to reduce the water hammer pressure, which is result of sudden closure of valve. Water hammer pressure is a result of sudden closure of valve. So, by the provision of pressure relief valve, we can easily release the water hammer pressure, and that particular valves are manufactured in such a way that they automatically open when the pressure in a pipe exceed a certain fixed predetermined value. So, as the pressure in the pipe exceed certain fixed predetermined value, what will happen? This valve will automatically open. So, this particular system is adjusted with the help of a spring. So, when there is a normal flow, what will happen? This section will close the pipe, this section closes the pipe. As the pressure rises, what will happen? The water applies pressure on the plate and the spring moves upward. As the spring moves upward, the valves open, and here from opening the water will move outside and reducing the pressure. After getting the pressure reduced, the valve automatically closes. Okay. So, the positive water pressure hammer developed, that pressure is a positive. So, where it should be provided? Again, it should be provided on the upstream side, such as valve may be provided on the upstream side of sluice valve, because of that the pressure will be easily released and the pressure acting on the valve is also low. If we are going to again, if we are going to provide this valve at the bottommost point, what will happen? There will be more pressure because of that head. This head is going to contribute more pressure on that particular valve. That is why we are going to provide again it on the summit points. Next one is check valve or reflex valve. What is check valve or what is reflex valve? Basically these are non-return valves and they are used at that point where we have to prevent the flow of water in backward direction or opposite direction. It means that if the flow of water is in that direction and we do not want that water should move like that when our supply is closed. So, what we need? We need the provision of reflex valve, and this reflex valve automatically closes. From this figure we can easily see that if the water is flowing in this direction, what will happen? This particular valve will open like that. As soon as the supply of water is stopped, what will happen? This valve automatically closes, and it get closed, the water cannot move in backward direction. Okay. So, this is used to prevent the entry of water in backward direction, and this check valve installed at the end of suction line. This type of valve is also installed at the end of suction line of known as foot valve, which prevent draining of the suction when the pump is stopped. During the operation of pump there is a continuous flow of water, but when the working of pump is stopped, what will happen? The water in suction end should be as such. So, in order to retain it, there is also provision of reflex valve, and that reflex valve is also known as foot valve. Next one is manhole. Basically manholes are provided for the purpose of inspection and repair, and that particular should be provided at an interval of 300 to 600 meter, and they are generally provided in a case of steel, hume steel or RCC pipe, and they are less commonly used in a case of cast iron pipe. Next one is insulation joint. What is the purpose of insulating insulation joint? This type of joint are basically provided at a suitable interval in order to insulate the pipe against the flow of stray electric current and also to check the electrolysis. For that purpose you can use rubber gasket, we can use rubber gasket or rings, which will restrict the flow of stray electric current and it will also stop the electrolysis. Next one is anchorage. At bends, what will happen? There will be development of unbalanced pressure. So, anchorage are basically used at bends and at the point where there is an unbalanced pressure, which makes them to pull apart and they will be out of alignment. So, in order to control this, what we need? We needs anchorage, and this anchorage will be formed by massive blocks of concrete and masonry, which absorb the thrust and the pipe will be in its proper alignment. Coming to next topic, that is leakage. Basically leakage occurs because of a poor plumbing or poor pipeline connection, or because of aged pipeline system, and if the aged pipeline is working under a high pressure, then there will be chances of bursting. And because of these leakage, what we have to do? We have to pump extra water, which will increases the energy consumption. It increases the energy consumption and resulting in an economic loss. So, this leakage is directly proportional to the operating pressure. Higher the operating pressure, higher will be the leakage in the water distribution system. How can we detect this leakage? This leakage can be detected by acoustics, infrared thermography, chemical tracers and mechanical methods. Among these methods, the most common method is acoustic method. What we are going to do in this method? Basically, in this method the leakage are recognized on the basis of characteristic pattern of sound that the leak create. The characteristic patterns of the sound that leak creates, on that basis we can recognize the leakage. Okay. In developed countries, leakage are the major component of water loss, but this is not true in case of developing country like India, but it remains an important factor of the water wastage. In India, the water loss is because of illegal connection, metering and accounting error, as well as pricing issues. They play a role in majority. Leakage control will be in a minor portion. So, how can these leakage be monitored or controlled? These leakage can be controlled in following steps. First one is preparatory work. What is preparatory work? In this we are going to update maps and database of consumer connections. Because of unavailability of data, we are not able to monitor the leakages. Residing population, water main walls, fire hydrants and the planning of activities. Okay. Test of for loss assessment and locating the defects, means we have to detect the leakage and we have to locate it. After detecting it, what we have to do? We have to replace it or we have to repair it. If there is no possibility of repair, then we are going to replace that particular component, and after that we are going to reassess it. If this particular problem cannot be minimized in a single go, then we are going to reassess it, and that particular program should be monitored continuously, and after that build a procedure and standardized activity applied to the considered system, and the staff involved in that particular activity should be properly trained, and the training should be of staff as well as training of trainers, and the trainers should be updated routinely. Okay. These all are the references. Thank you.